But the moment that you start adding other operators with other techniques, tactics, procedures, whatever it is, into the airspace, you create complication and by extension, risk that cannot be mitigated if you're talking about community-based traffic management. There needs to be one codified rule of how to do things. And that's usually how an air wing is successful, because that's multiple squadrons living together and operating together under one air wing commander. And that has been something that the United States Navy, and I know the United States Air Force does this too, but we've been doing this for 100 years. So why we're trying to make up some new methodology for aviation operation with complexity of interwoven components and saying that this is going to be the thing that works baffles me. We have 100 years of data to support doing it the traditional way. I have no data to support that the way that people are suggesting will work. And I'm not saying it's not worth the study, but I think from a safety and speed of integration perspective, it's very difficult to enter into a conversation where somebody says, I quickly want this to happen. I quickly want to get my return on investment, but I want to do it in a new way. Well, if you quickly want it to happen, wouldn't it be easier to conform to the safety standards that we already have in place so that you can get that application to work? Because new and fast are two things that are counterintuitive to one another.
Welcome to The Vertical Space, the podcast at the intersection of technology and flight, featuring deep dives with innovators, early adopters, and industry leaders. We are your hosts, Jim Barry from Celerity 05 and Peter Shannon and Luka Tomjanovic from Radius Capital. At Celerity 05, we believe that breakthrough air transportation capabilities come from leveraging current and emerging technologies, and that companies achieve profitability through relevant technologies, strong teams, and a deep understanding of the aviation market. Connect with global aviation experts at celerity05.com for feedback and recommendations to chart your path to success. At Radius Capital, we invest in early-stage deep tech that redefines what is possible in aerospace. We partner with founders building next-generation aerospace capabilities, from advanced design and development tools to the digital transformation of the flight environment, novel use cases and forms of flight, and the software and systems that make them possible. If this describes you, reach out. We're excited to connect. All right, let's dive in.
Hey, welcome back to The Vertical Space and an active discussion with Chris Hewlett, former Navy commander and helicopter pilot and director of Project Ultra, which stands for UAS Logistics, Traffic, Response, and Autonomy, working for the development and implementation of new operational capacities for advanced air mobility, UAS, counter-UAS, and UTM for the Office of Undersecretary of Defense, Acquisitions, and Sustainment. Chris is always a delight to speak with. In a world where people talk about rapid change and possibilities, Chris understands the bedrock safety culture of aviation. And as he welcomes change, both in commercial and the military markets, he understands that future technology integration will have to respect the traditions and experience of aviation excellence. Hey, Chris, thanks for joining us, and to our guests, enjoy our conversation with Chris Hewlett as you profitably innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by UAvionics. UAvionics is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let UAvionics help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. UAvionics has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace.
Commander Chris Hewlett has 30 years of experience in aviation operations, safety, modernization, system optimization for next-generation aviation systems, and assessment of developing and deployed aviation command and control systems. As I mentioned, he is the director of Project Ultra. Chris is currently the president and CEO of C. Scott Solutions, which contracts to Grand Sky and the Grand Forks County team. He has extensive experience supporting the U.S. Navy in modernizing rotary wing manned and unmanned aviation through integration, implementation, and test evaluation of new systems. Before consulting, Chris spent 21 years on active duty in the U.S. Navy, flying helicopters, drones, and leading large teams of sailors to integrate and test new aviation system designs through operational test and evaluation for the purposes of engineering design validation, enhancing safety, and smoothing the acquisition management lifecycle. In the areas of UAS, he has managed organizational change and efficiency and developed individual and team talent.
Chris, welcome back to the Vertical Space. We're so excited to have you back.
Yes. First of all, thank you so much for taking the time with me today. I know you guys are tremendously busy, and I greatly appreciate the opportunity to share thoughts with you.
Our pleasure. You know that usually we ask if there's anything that few in the industry agree with you on. Is there something that you would like to comment on that question, or maybe comment on the answer that you gave 2.5 years ago? If you can remember.
I think that everybody thinks that the solution to integration of unmanned systems is community-based traffic management, right? Which is see and avoid and talking to each other. And I think that is a fundamentally flawed idea. There is a tipping point that I have been working on as part of my doctoral thesis with regards to how much the airspace can actually handle before we become more likely to have a mishap, which would set the industry back in decades. So I think there's the right mix of air traffic management. And to that end, I don't think that the terminology UAS transportation management is at all applicable, because in my mind, it means everything and nothing. It's just traffic management, but traffic management for the next generation, which would be ubiquitous to the user or the operator or the methodology in which it's being flown in the airspace. That is the solution set. And it's a more difficult solution set, to be sure, but that's the reason why I think people from an industry perspective disagree with me, because it's not easily attained. So I'm pushing forward with the more difficult side of the house, because I think if we solve for the difficult, we automatically can incorporate the easy, instead of trying to solve for the easy and then figure out the difficult, which trying to figure out difficult in aviation doesn't usually end well.
So first of all, just for clarity's sake, what is it that most people disagree with you with? Is it that start with the easy and get to the hard? And what you're saying is start with the hard and get to the easy?
No, actually, I think what they disagree is that community-based traffic management would work, and that UAS transportation management is actually the solution. You can't create a solution with something that's completely meaningless, because what is UAS transportation management? It's just transportation management for unmanned aerial systems, but how does that integrate into the current traffic management scheme?
Okay.
So how does UTM and ATM merge? And what does that mean? UATM? I know. So again, it's just traffic management.
Excellent.
So
now I am going to clarify terms here just for a second. You're using the word transportation. Do you mean to say UAS traffic management? Or
sure.
Are you? Okay. So give us a scenario of how people, those who may disagree with you, see a world 5 or 10 years from now. And then what is your world 5 or 10 years from now, and how are they different?
Right. So I think 5 or 10 years from now, ideally, when you talk to members of the industry who perceive an elegant network of data exchange in the low altitude airspace, where vehicles that are moving packages or people are exchanging their information freely with the network to tell people where they are, or there are remote pilots who are telling each other where they are. Very similar to what Lance is, very similar to the rules of the road that we now have, where you put information out there for people to understand. I mean, I'm here in North Dakota, and this is the Vantis network, right? It's awareness. So that interchange of information, and then the reliance on somebody to take it and then broadcast it to somebody else, and for them to understand that's what they need, the area that they need to stay out of or they need to be cognizant of. I think the more elegant solution, and certainly the more difficult one to solve for, is a ubiquitous system that does not care what the operator is, doesn't care how the operator is operating, but what it's managing is the safe separation of aircraft. And that would necessitate a data exchange architecture that is probably a little bit too advanced right now for us to handle, with a human either in the loop or a human on the loop can validate the things that would be important. And the way I see it is very similar to what an Air Force base has to deal with on a regular basis, which is I need to be worried about all the traffic that's coming in, and I need to be worried about the traffic that I don't want to come in, right? And so that's where the merged realities are starting to hit, in my opinion, because how can you have a community-based traffic management system that effectively manages counter UAS and says stay out? That's where I start losing the connectivity here, where if you're non-cooperative and I can't rely on you to just stay away, then how do I have control of that situation? And if you're non-cooperative or if you're unaware, how much more danger are you creating in the airspace? And then I extrapolate that out to 1,000. Of the 10,000 drones that we have operating in the airspace, 1,000 of them are non-cooperative. How do I even remotely deal with that situation in a community-based traffic management environment in which everybody is required to be cooperative? So the easiest thing to do is go to the lowest common denominator, same thing that we do right now in aviation, which is you will all follow the rules. You will all let me know where you are. And if you don't, then you just don't get to operate my airspace. So I think that is the difference between what is projected to be the airspace of the future and what I see the airspace of the future is, because to me, the most difficult thing is when you talk about utilization of unmanned systems and the return on investment that you would like to have. The scaled order of magnitude of drones operating in the airspace is insurmountable for any community management system. It is something that would have to be automated. And in order for that to be automated, you'd have to have a common operating picture. And as I start teasing all of that out, the natural progression for people is to go, okay, well, there's no way a room full of air traffic controllers could handle 40,000 air vehicles. I mean, that's just not even feasible, right? So what's the level of automation and integration that actually would make sense?
It's funny, people have said about UTM versus ATM, they said it becomes ATM really quickly when something goes wrong. And what you're saying is let's plan for a future where we have more sophisticated systems than a community-based system, or what many people consider traditional UTM, perhaps.
Right. And then that layer of automation just adds simplicity and adds safety and oversight. And it also creates standards, right? Community-based to me doesn't sound like standards. And I've said this before. I mean, I learned these lessons the hard way flying for the military, especially rotary wing. And where I disagree about the community-based traffic management is that sounds like the response that we had for Hurricane Katrina, which is literally just 50 or 60 helicopters operating simultaneously in a search and rescue environment with absolutely zero air traffic control because everything is lights out. There is no power. We're not talking to anybody. So in my world, operating that way for 2 weeks in the continental United States of America, in the city of New Orleans that was underwater, it was a miracle that we didn't hit each other. And that was only 50 helicopters. When I extrapolate that out by an order of magnitude, even 500 drones sounds to me almost impossible from a community-based traffic management perspective. 500 drones is not a lot of drones either.
Chris, let's reconcile this view with the ongoing operations that we're seeing with drone delivery companies around the world, where they either are using a third-party UTM provider or they have their internal UTM systems, but they are providing information based on certain standards that have been adopted out there in terms of interoperability and the message sets and the data exchange protocols and all of these things. And they are showing that even certainly at the low scale that they're operating right now, relatively low scale, they can do this safely, and they can not only deconflict their own fleets and their own operations, but between operators and also between operators and law enforcement that's flying in the low level. So the system is working. What is it that they are doing wrong in your mind, and what should their operations look like today with your idea of UTM?
No, that's a great question. And they're not doing anything wrong, by the way. I wouldn't suggest that they're doing anything wrong. If the architecture that they set up is capable of merging realities with everybody else's architecture. So I'm going to give you an example. Company A, Company B, Company C, Company D are all package companies. And they're large package companies. These are big box companies. If they want to move into an area and establish drone delivery and create some kind of return on investment, and they say, in their model that 1,000 drones is what's going to get them return on investment. And they do everything that you just described, Luca, which is manage the system. Who develops and who determines who has priority to deliver when? So they're running their own independent system. Do they have to grid off a city and one company is only allowed to deliver in the north? One company is only allowed to deliver in the south? It doesn't make sense. How do you integrate all 4 companies into one localized system for delivery and prioritize? Does one company only fly between 7 o'clock in the morning and 9 o'clock in the morning? And then, because where's the deconfliction strategy? Because you're managing your own fleet, but you have no idea about everybody else's fleet.
Okay, so take us into that with respect to what is being demonstrated in the Dallas suburb with the Keysight. Because
right. So,
at a headline level, we know that there is some degree of data exchange and coordination amongst operators doing this, but take us this layer deeper to what you're talking about, and what have they demonstrated there and what remains to be done?
Yeah, so the remaining to be done is what we're working on with the DoD, which is the full-scale integration, right? So if we take the microcosm of an Air Force base, like I said, what we have to do is coordinate all things aviation. That means here in North Dakota, we're about ready to slide into the month of November, which they call no-fly November up here. And it's not because it's so cold, it's because of migratory birds. Okay, so what I'm suggesting to everybody is there are partitions and pieces of the airspace that in the solution that is currently being articulated do not incorporate all of the airspace. That is, if you have a solution that just deals with you and your operators and fleet management and fleet scheduling and where they are and how they're deconflicted with each other, that is one piece of it, certainly. However, that needs to be bolted into the other pieces, which are somebody else's, like company that is doing exactly the same thing in exactly the same airspace, the counter UAS component, the first responders component, and then the other things that exist in the airspace like birds. And then how do I deconflict all of that from the unintended consequence of a 16-year-old with a drone that he can buy at Walmart and go flying anytime he wants, which is the non-cooperatives or the people who are ill-intentioned to do things. When you take a look at that bigger problem, the Keysight is very important. It's getting data, and that's going to help us integrate. The idea of community-based traffic management is not a bad idea. It's just I don't think it's a complete solution. I don't think it's the end state, right? It's a portion of what we need to collect data on and then put into an end state.
But you're even proposing, though, it's not even a first state. In other words, you're proposing you should start with what's difficult rather than what's easy.
I think that's the best way to do it. And fortunately for me, the Department of Defense is starting to agree with me. And so what we're having is the conversation about how we build the Air Force's version of what the airspace looks like for the future. And then that will become the DoD because they're the executive agent for airspace management. But if you think about it, right, a base commander has got normal operations. Here at Grand Forks Air Force Base, that includes manned and unmanned traffic. I've got pretty large aircraft flying around. I've got Predators and Reapers flying around. There's Global Hawks here. All small UAS operations are here. And then there's right next door at Grand Forks proper is UND's flight school. So this is some of the busiest airspace in the country, just from a volume perspective. And what we're doing is recording all of that data and talking about how we see it. And by the way, it's not just that. I've also got farmers' fields with aerial applicators and pop-ups happening all over the place with crop dusters. So we're dealing with all of that and understanding what the information exchange needs to happen to be able to do all of this from a regulatory perspective and feeding that back into the DoD and at the UAS XCOM level, having the conversation with FAA saying, hey man, these are just data sets for us to provide with you. But when you talk about an integrated airspace system that incorporates both manned and unmanned traffic and a communication system that interchanges information, that's a Tuesday at Grand Forks. Okay, so the Dallas Keysight to me is important because it deals with very small UAS, but we don't deal with just very small UAS. I've got a Skydio drone flying on top of a Class 3 drone with a B1 in the pattern and an MQ-9 on downwind. And like I said, that's a Tuesday at Grand Forks.
Chris, is there a line that you draw where community-based traffic management and the current concept of UTM and USpace where that does make sense and where it is a more favorable route to go and start with something that's more operationally constrained, controllable, that grows from there as experience is accumulated, as lessons are learned, as additional data is integrated into the operations. What's the argument in favor of going down this route? And where do you draw the line in terms of either complexity of operations or the size of the aircraft or the airspace that's flown into where this model breaks? Again, your
Yeah, and
perspective based on what you're seeing in the market.
part of it is deals with the market, right, in the industry and what people are doing. And I think that's very smart and it's very savvy and they're getting lots of information. The other part of it is traditional aviation methodology. And that is this way, right? Luke, you have a squadron. You operate your squadron and you have your SOPs and you do things the way you do. I have a squadron and I operate my SOPs and I do things the way I do. When two squadrons meet together to start cooperating, are they automatically operating the same exact way? Or does there have to be an information exchange and an understanding and then a training to merge the realities between those two squadrons? And the reality is yes. There is no way that two squadrons come together and operate exactly the same way. And there is because there are personalities and there are desires and there are wants from every single aviator. They do things just a little bit differently. Those subtle nuances can lead to successful, safe integration of two squadrons or very unsuccessful, I've seen in the past, integration of two squadrons. If we dissect that and distill it down to integration of unmanned systems, if you have one operator that has one set of rules and one geographic location, what you're talking about works. But the moment that you start adding other operators with other techniques, tactics, procedures, whatever it is, into the airspace, you create complication and by extension, risk that cannot be mitigated if you're talking about community-based traffic management. There needs to be one codified rule of how to do things. And that's usually how an air wing is successful because that's multiple squadrons living together and operating together under one squadron, under one air wing commander. And that has been something that the United States Navy, and I know the United States Air Force does this too, but we've been doing this for 100 years. So why we're trying to make up some new methodology for aviation operation with complexity of interwoven components and saying that this is going to be the thing that works baffles me. We have 100 years of data to support doing it the traditional way. I have no data to support that the way that people are suggesting will work. And I'm not saying it's not worth the study, but I think from a safety and speed of integration perspective, it's very difficult to enter into a conversation where somebody says, I quickly want this to happen. I quickly want to get my return on investment, but I want to do it in a new way. Well, if you quickly want it to happen, wouldn't it be easier to conform to the safety standards that we already have in place so that you can get that application to work? Because new and fast are two things that are counterintuitive to one another.
Okay, let's put a pin on this and come back when we talk about Part 108. Let's talk about how the market has evolved over the last couple of years. What did the industry get wrong in its predictions versus what actually played out?
I mean, it's fair to say, right? Because I'm not saying that people should not have invested or should not have bought into this, but, we're not flying anybody around in the LA basin. I'm not seeing anybody flying around anywhere in the back of an electric vertical takeoff and landing air vehicle. So, and a lot of people bought into that because the statements were made. And I don't think we're ready for that. I think we got a lot more constraints and restraints that we need to argue for. This isn't even about airspace control. This is just about the physics of flight, right? And I'm watching these hybrid electric vehicles that are out here. They're not even just all electric. These are just hybrid vehicles, just struggling to perform at the lowest level when there's not even a passenger involved in it. This is just logistics and military utilization assessments. So the statements that have been made about what the future in the very near term was going to be with regards to electrical vertical takeoff and landing and passenger movements, I think were grossly inaccurate.
What about on the lower end of the market?
Lower end of the market, I think we're doing great. I think, and we'll get into the conversation about 108. I think there were some assumptions that were made that are going to be beneficial in the test and evaluation perspective, but I don't see the scalability and the return on investment on the lower end market based on the notice of public rulemaking coming out on 108, but we can get into that later because I don't think it's scalable.
How do you feel about the statements being made by the electric or hybrid VTOL companies today? If 4 years ago or 3 years ago you said, I don't think it's going to come about the way they're articulating it, how do you feel about the statements of today for the next 3 or 4 years?
I think it's difficult. I think it's difficult to understand that the industry as a whole has scattergun solutions, right? And none of them are bad. They're all good. I actually love that energy. The thing that I'm having a hard time, and you guys spend more time in this than I do, the thing that I'm having a hard time wrestling with is the definitive statement about this is the solution over here. I think it's a viable conversation, but when somebody makes that statement to me as an aerospace engineer person, I want to see data associated with the statement. So I don't buy into it because it's no different than the market analysis that takes a look at statements that, just because the Secretary of War, I have to say it the right way, the Secretary of War says we will do this, it doesn't mean that we will actually achieve it. I mean, we won the space race by throwing tons of people, human capital, and money at the space race. So if we're, as a country, making a decision that we're going to win this particular race by doing the same thing, then I say we're going to be massively successful. I truly believe that. But if the statements are being made, but we're actually not doing the thing that we need to do, which is throw the money at it, then I'm struggling with how it's going to happen. So
the other thing, Chris, and stay with me on this because I'm going to try to bring this around to your opening statement. The commercial eVTOL, hybrid VTOL companies, in order for them to be able to get the returns on the capital, they're going to need to be fully integrated into the airspace.
Yeah, there is no, we went
scale. To be able to scale, they need to be fully integrated. And this is kind of the warning you're giving about where most people don't agree with you. In order to get the returns, they need to be fully integrated. In order to be fully integrated, they need to be at the point where you're saying people should start.
Yeah. And so it's even more complex than that, Jim. It's really, to me, and this is because of previous to this, as a consultant, I did a lot of work now running this project for Ultra in my own company and everything else like that. But a few years ago, when I first was meeting Luca and Peter and having all of these conversations, I was asked by some auto manufacturing companies to do a make-buy analysis on specific development of vertical takeoff and landing air vehicles because of my background with rotary wing and my business analysis. So I brought a team to bear on this, doing make-buy analysis. One of the critical moments that I completely understood how crazy things can be from people's perspective of figuring out business is when they were getting down to the make-buy analysis, and I asked them from a scaling perspective what the annual manufacturing for vehicle numbers was going to be. And they actually, with a straight face, looked at me and said they want to make 4,000 air vehicles a year. 4,000 air vehicles is an order of magnitude higher than any other production company manufactures annually of air vehicles. And these are companies that have been in business for 50 to 100 years. So I naturally asked the question, you have an expectation to manufacture more than has ever been manufactured in aviation before. Can I ask you how they're going to do that? And they started saying things like resin transfer molding, all things that are not approved for flight critical surfaces. And then I said, and then I'm also curious about how you're planning on doing work in process, because there's only 365 days a year. So how do you build, functionally check flight, disassemble, transport, reassemble, functionally check flight again, 4,000 air vehicles that need to be disseminated into the market? That's not even possible. I just don't even know how you do that and maintain what would be considered FAA standards for safety for transporting people in the air. So again, there's a misperception because these are auto manufacturers and they're used to making thousands of cars a year, right? But they had aspirations to become an aerospace company. And there are certain truths that you have to adhere to, which is no, just because you are an auto manufacturer and you have glass You say, well, I'll achieve efficiencies by using the same glass that I would use in cars for my aircraft. And you have to point out to them, well, aviation glass is called Mylar, and it's very specific. And there are 15 companies out there that make Mylar. So you're going to have to buy it from them in order to put it in your aircraft. Those are the kinds of things that the early days of trying to figure this out, companies they're not thinking about. They're just making a statement. In order for me to be successful, I'm going to make 4,000 aircraft. All the aircraft manufacturers are just giggling. They're like, that's not even possible. I mean, even in World War II,
To say nothing of the commercialization, to say nothing of the air traffic integration and the like.
Right. So, and then once you've scaled to that level of production, that means that begets that there would be a demand signal globally for what you're talking about.
Well, all right. Well, you mentioned World War II, and the auto manufacturers did in World War II produce aircraft. They were the backbone of aircraft production in the United States.
100%.
What has changed about the nature of aircraft production and about the nature of safety certification since those days, which were very high volume, to
Right.
the paradigm that we exist in now?
So I will use the Hellcat as an example, and everybody knows the story, but that was called the Ensignator. And it wasn't called the Ensignator for a good reason. It was literally more ensigns in training died than the Japanese shot down, point blank. So I would say between then and now, our safety standards are a slight bit different compared to the expectation is not we're going to crash. The expectation is we're going to make it from point A to point B and everybody's going to be alive and landings equal takeoffs. In World War II, in order to win a war, the expectation was we're going to throw a wave of humans, D-Day, the fight with the kamikazes, the fight with the Luftwaffe. It's just, we need to get more mass downrange. There is no desire to win an engagement in which an exchange of life is the ultimate end state. So we're not fighting a war against an actual enemy. We're fighting a war against time and desire. And the time and desire does not drive the Federal Aviation Administration or the federal government into a position where it's going to accept the risk that was accepted in World War II, which is if we don't do something about this, the Nazis are going to take over the planet. We're not in that situation. So I think our desire to change our financial situation such that we can take advantage of these unmanned systems has pushed us in this direction. But we are getting to a point where unmanned systems, based on the war that we're seeing in the Ukraine and some of the evolution of these things, is starting to drive us into a methodology that's very similar to what we were dealing with when the first counterinsurgency stuff was being talked about at the Pentagon. So to me, this is airborne counterinsurgency that we're now starting to deal with when you start taking a look at the Ukraine, because that's the real driving impetus behind all of this. It's not commerce. It's the speed of and edge of the battle space is really starting to propel us down this road. If it was just businesses making money, I doubt that we'd be moving with any more alacrity or speed than we are right now. But the reason why we're doing what we're doing is because of all of the first-person videos that we've seen out of the Ukraine, which is another wartime footing kind of environment. I don't think anybody wants to create the same situation that we had in World War II, but that's, to me, what's driving the industry right now is the need for response to small unmanned systems that are basically airborne IEDs and the counter UAS environment.
What market bottlenecks that people assumed would be short term have proved to be more structural?
You're saying what is stopping progression right now because we've bought into it, or are you asking it slightly differently?
Slightly differently, where people thought that something was standing in the way of market scaling that was going to be solved in the short term, but looking back, it is more of a structural problem that the industry is still grappling with.
So from my seat, and this is something that I think the DoD is struggling with, there is still not a great understanding of how to convert and or adopt the electric distributed propulsion side of the house. And I'm not sure that I'm completely bought into lithium ion or the energy density that's associated with heavy lift and what can really be done with electric distributed propulsion. And I think we missed the boat on adopting hydrogen in some of our early tests. So the energy management situation is a lot further behind than I thought we would be at right now. So energy density is everything. And it just has to do with endurance, range, payload capacity, all of those things comes down to energy density. And so the full press into electrification was great at the beginning. And now more of class twos and class threes are starting to throttle back to hybrid electric. Like one of them we're dealing with up here. It's a really elegant design system, but it's a two-stroke engine that actually has nothing to do with propulsion. All it does is push an alternator and feed the batteries. So once the fuel is exhausted, the drone itself still has 45 minutes to an hour worth of flight time, since all the propulsion systems are based on batteries, which is an elegant design. And they're actually going to improve efficiencies and reduce weight by going away from the two-stroke to a four-stroke diesel engine, which weighs less and has better endurance. So I think everybody's trying to solve for the same thing, which is how do I fly longer, take more, all those kinds of things. But then in the early days, it was all about electricity. We're going to do this with electricity, right? And swap out battery packs and recharge and everything else like that. People are now starting to understand that creates a lot different complexity, especially when you start scaling at a large distribution facility. How do you recharge all of these drones or swap batteries and recharge the batteries that have been swapped out and get things on and off a platform when your battery charge times are not instantaneous? It's certainly not like pumping 55 psi avgas into a jet, which you can do in a matter of minutes. You cannot scale to energy density in a matter of minutes with lithium ion. It just doesn't work. So I think that has become a point where the industry kind of stalled for a little bit or plateaued and said, hey, this way. Now they're backing into a hybrid electric solution, which has its own different set of complexities.
Where have you seen the most adoption, both on the defense and commercial side of the market?
It's all logistics, right? So, and ISR. So when you talk about the merged reality between defense and commercial, or even just private sector, right? Defense and private sector, because some of it's not commercial applications, it's first responders. So examples are lost personnel wandering around. The police use these things a lot. The fire department uses them a lot. The Forest Service uses them for firefighting. And that's all intelligence, surveillance, and reconnaissance, which bleeds over into the DoD side of the world. So elegant designs, that meets a good tipping point where you have commonality between DoD and private sector. I think logistics is absolutely huge, especially medical supplies. When you take a look at the things that are being done by all the great companies that are doing amazing work in the private sector with medical supply delivery and blood delivery, the DoD is doing exactly the same thing. So where are their commonalities? Because that's what I'm trying to enhance, right? Because if the DoD spends a little bit on that, it eases the strain on industry for the ROI and what they expect back. And the industry can evolve on the backs of the DoD pretty well, because those are easily integratable. But again, that goes back to the common architecture, which is my defensible moment, which is if industry goes off by themselves and creates anything that the DoD says, well, I don't agree with that, or it doesn't work for me, we now run the risk of having a city that has a common operating picture for the city, and the base that's associated with that city has a different architecture. So how does that work if the drones from the base are supposed to integrate with the drones of the city? Because that's like cars coming, that'd be like you saying you have to park your car off base and take a base car to go on base.
But that's a relatively niche use case, right? Where you have this exchange between a military and a non-military environment. There's plenty of market outside of that scenario where you don't come anywhere near a DoD base. You don't have to.
That is true. However, the hardest thing to solve for is let's just do San Antonio, Texas. Great example. Probably arguably one of the most difficult places, simply from an airspace management perspective. There's 3 bases that surround San Antonio and an international border, okay, that you have to manage. And so within that airspace, you'll see everything from Air Force to package delivery to cartels. flying drones to move drugs around. So that airspace is completely the wild, wild west. It's where Department of Justice, Department of Homeland Security, DoD are starting to do the aggregation, integration, and study around just awareness, just knowing what's there. But if you can start extrapolating that out to various different areas, I think it makes it better because that complicated airspace will get you to a solution set faster than going someplace and working one avenue of what I just talked about. Okay, if you solve for one data set in Los Angeles or Chicago and then took it to another city that is got what I just mentioned, which is all of those agencies associated with it, how does that solution set help the other city? So the one-offs are absolutely something that we can manage. But I think most people would argue that their airspace is fairly more complicated than a single vendor.
I would agree. The one thing that I would slightly push back on is the pace of the industry has been far too unacceptable in terms of agreeing on how to do certain things and standards. And if you look back to remote ID, if you look back to
Sure.
many of the issues that we've had over the last 10, 15 years, if we wanted to start from this high-end, fully encompassing, comprehensive solution, we would have to wait potentially 10, 15, 20 years. Or maybe we just say, hey, we can't do this.
I got it, right? So
it's either waiting another 10 years, hoping that we collectively somehow get to the solution, and then all of a sudden we're like, all right, we've got the answer. By that time, it's totally obsolete because the industry and technology moved on. Or we say, okay, let's remain safe, absolutely, but let's start with something so that we can get some mileage under our feet.
okay. And I love the fact that you push back because that's exactly a perfect segue into talking about what we're doing here. Okay, so I've got the Air Force Battle Lab here. I've got Task Force 99 here. I've got CENTCOM here. I've got DARPA here. I've got the Federal Aviation Administration. I've got more federal partners than you can possibly imagine here. And what we're doing is moving at the speed of the battle space. Some of the people who are here are actually forward deployed in Qatar and are here right now to help us because we're creating interoperability and common operating pictures with not only the link, the control, the C2, and the mission and the tasking, and the air vehicle, such that what we're trying to do is develop a process where somebody in the CENTCOM AOR can log into a system and operate a drone here for training environments, pull in tactics, techniques, and procedures that they want to validate for the battle space that they're dealing with, validate them in a test environment, go through the V&V, write the new tasks, and then accept them in the battle space and employ them tomorrow. That's a 4-year RDT&E mission truncated into 4 days. If we can do that for a theater component commander, I think we can integrate stuff faster than the process that you're saying is currently in the mix. And the way to do it is to break down the barriers that you've articulated are in place. And that is being done because the DoD is assimilating information and then taking it to the highest level. And I'll give you an example. We are providing feedback at the UAS XCOM for the interagency on process and procedure and policy that is inefficient and doesn't need to be in place anymore. And there is a significant difference between the early days of the integration of unmanned systems when, in my mind, the methodology that was applied by the federal government was to allow normalized institutional inertia to slow the process down a little bit and kind of keep safety there. There are some things, as you've rightly pointed out, that need to just be changed and maybe improved from an efficiency perspective to speed the process up to an adequate level where we can actually start doing these things. As an example, just a transmit license for the FCC to be able to use a transponder in a geographic location is an onerous process, even though that particular transponder might be government furnished equipment that is used on a daily basis. But because of the way the process is set up, for the DoD even to apply for a geographic shift for a transponder come from Pax River at Wolf Field to here took us 2 weeks initially when we started it. That process has now been changed because of our feedback through the DoD to the UAS XCOM to FAA to say, is this really the direction that we needed to go? And the legacy was slow things down, right? Same thing with the SecDef memo that we talked about, Luca, which is the COTS ETP process. That is now gone, okay? And that original process was set up to really ensure that everybody was doing due diligence to where the parts came from that we were going to start building drones with so that we don't wind up with any foreign influence or any foreign parts, ByteDance stuff, that kind of stuff. So now it went from a board that meets every 2 weeks to NE06 can sign off on the risk that's associated with COTS ETP once the due diligence is done. That sped the process up tremendously. So I think it's on us to take a look at the current process and provide, instead of the statement being to the federal government, which is the typical industry statement of you just need to change your process and speed things up, to, hey, I've done your process this way. And I now have some comments for you of how you can improve your process or speed it up based on having done it the way you wanted me to. Now I'm asking you, can we efficiently, effectively, and safely speed this process up? If we can do that as an industry, we can start breaking down some more barriers, getting more data, freeing up more processes, and speeding the advance up. So I appreciate your pushback, but I think we can achieve way faster than 10 to 15 years for integration if we follow the right methodology.
I know we want to talk about your views on Part 108. A quick question. Are the results of the work at Grand Sky and Ultra more applicable to the military application or to the commercial?
More applicable, actually, ironically, to the commercial application, because all I'm doing up here is taking packages from point A to point B. I mean, our first series of flights back in April were just to prove out the concept of operations that we validated in simulated world, is taking a 10-pound package 60 nautical miles north, but not doing it in Class Gulf airspace. We did it in Echo airspace, departing Class Delta with a squawk code, talking to air traffic control, landing at an off-site facility, unloading cargo, and returning back, all in coordination collaboration with the air traffic management system. So that to me that's not even a DO, even though it was done under a DoD umbrella, that's just package delivery. That's all that is.
But couldn't one argue that because of your introduction of the DoD component, even with your example of in southern Texas, aren't you introducing a level of complexity you wouldn't necessarily see even in New York City? In other words, aren't you solving for something that is not necessarily the greatest example on the commercial side by introducing DoD?
I mean, that you could make that argument. I would disagree with you because in the complexity of what is required, flying into an active Air Force base is way more complex than flying someplace in New York.
Wow. All right. You're making
the Air
news,
Force,
man.
the Air Force is very strict. I mean, you have to deal with not just the FAA. To fly someplace anywhere in the country, you have to deal with the FAA, except for below 400 feet, right? Because they don't deal with that. We're different. Even below 400 feet here, we're dealing with somebody. So I don't see the level of complexity out in the middle of Gulf airspace where you can fly around and do whatever you want as a complex operation. That is a standalone Part 107 operation. Even if I want to do that here, I still have to coordinate with the United States Air Force because this is their airspace. It's Class Delta airspace. This is not Gulf. The complexity of doing something like that requires more interoperability. And we've developed our airspace integration service. We use federal USSs. We have a ground-based sense and avoid system. We are responsible for the safe integration of small to large UAS in this airspace system in collaboration with FAA and the United States Air Force.
Great. Chris, fascinating. This is really interesting. The kind of the military underpinning being the foundation for what would be the future of the commercial space. That would be interesting to drill into more, but we don't have the time right now. But what we are interested to know, if you are going to make changes to what's been proposed for Part 108, what would you change about it based on your very confident stance of how you think the things should be in the future?
Oh, yeah. So my confidence stance is simply my lens for aviation safety is it's very narrowly focused. And as a guy who integrated unmanned systems for the DoD when I was active duty, it's very narrowly focused, and that's just my experience. But 108 to me, not saying it's a bad rule, not saying it was done the wrong way, I'm not suggesting any of that. What I'm saying is that if you are creating a rule for rural package delivery, which is what I understand the expansion of that is too, and you're basing it on, again, from an aerospace perspective, data sets that you validated, which were done specifically for inspection of infrastructure in an easement that was owned by the company that was doing it. How is that a like-to-like comparison to delivering packages over somebody else's property? I'm not understanding how those two things connect. So, not saying the rule's bad, not saying everything. I'm just, from a purely data analytics perspective, how is that a like-to-like comparison? Now, if 108 was designed to open up the aperture for rural and remote inspection of infrastructure, I would have been, well, that absolutely makes sense because that's what it's based on. But what I'm doing here at Grand Forks has more application to 108 than the data set that was used for it. Because I'm actually delivering something in a rural and remote area. But I'm not understanding how inspecting a power line is synonymous with rural and remote delivery. That's, I guess, what I was trying to say about 108, because it just, from an aerospace perspective, it's not a like for like.
What are some of the proposed parts of Part 108 where you see this biggest disconnect between inspecting infrastructure in the rural area and some of the other use cases that will be enabled by 108?
So good question. So are there altitude restrictions for inspecting infrastructure if you own the infrastructure? And I think the answer is no, right? You just fly wherever you want over your infrastructure. Will there be altitude restrictions with rural and remote delivery? Yeah. Wildlife refuges, tribal locations. You can't just, the most effective way for package delivery is point A to point B, right? So how do you mitigate that? I'm not, again, a straight line linear inspection is at a single altitude, and there's no concern for if you crash on it because it's your property and it's your drone. But what are even the insurance implications of what we're talking about from a rural and remote package delivery perspective? Because I know what ours are. They're
what's 108 saying about this? How is it
I don't
framing
think
it?
108 even addresses insurance, right? Because that's not on
or altitudes of what you were talking about. Is this an unsolved problem? I mean, we were talking about this offline, but
yeah.
who
who
owns the airspace? It's the FAA, right? Just because they don't want to control the airspace below 400 feet doesn't mean that they are still not legally responsible for it, right?
Well, I mean, is that the question? Is that the question? If you don't want to manage it, does that mean you're not legally responsible for it? Because right now, I would submit to you that if somebody does something goofy with a drone in Class Gulf airspace, the FAA just kind of goes, okay, did you hurt anybody? Because there's a requirement for NTSB to come in if there's a certain amount of damage above a categorical variable like loss of life or a certain threshold. But how many situations of people going out into the middle of nowhere and crashing a drone that's $14,000, which actually hits the threshold, are unreported and therefore unknown to NTSB and FAA? That changes when you create a business model around a rule that allows people to operate. Because now, isn't that a 135 operation, technically, package delivery? And do you have to have a license to do that? Or do you not? Because it's just 108.
Yeah, I guess I'm still a little bit confused with definitions because even if the airspace is controlled or uncontrolled, the airspace, all of the U.S. airspace is still sovereign and falls under the jurisdictions of the FAA.
Completely agree with
So,
you.
so what exactly is the concern here? That if an accident happens, well, number one, these operations are insured, so that's another argument for it. What really is the problem statement?
I think the problem statement is that point blank package delivery is 360 degrees. Linear inspection is not. So from a utilization perspective, we have opened the aperture up to package delivery 360 degrees in rural remote areas and based that on a altitude restricted, geographically restricted, straight line inspection process. And that's not mathematically sound, in my perspective.
Even with the different risk acceptance thresholds and different population areas, there are ways that the FAA, similar to how SORA is doing it, or JARUS, and which was adopted by EASA, it all is risk based, right?
Sure.
So there are measures put in place to limit that exposure to people on the ground and in the air. You think that is still inadequate?
I wouldn't say it's inadequate. Okay. What I'd say is it's incomplete. To me, the study just requires a little bit more data, probably some more proof points. And everybody in the conference, I'm just trying not to mention names, right? But everybody knows where the data came from. And it wasn't intended at the time, in my opinion, in my estimation, it wasn't intended to be a research study. It was just data, right? Which is valuable. I'm not saying it's not valuable, but I think we're fundamentally missing the boat here. Did we set out with the operation that we're talking about, the data that was being captured off of it is a aerospace study that was going to inform a rulemaking process? No, it was not. It was a novel approach to power line inspection. So what you're telling me as an aerospace engineer and an aviator is you're using a novel approach to linear asset inspection as a justification for a rulemaking process for rural and remote package delivery. And when you say it out loud like that, should be cause for concern. That's what I'm saying. Because to me, that means it's insufficient to be able to do. If you had done it reverse, by the way, if you had done rural and remote package delivery as a validation for linear asset inspection, I would say, yeah, I could actually see that. Because you've done a lot more than what the application is that you're trying to move towards. But the data set is incomplete. And that's just me being candid about the research that was done or the validation that was done. If you want to say you can do it and say you're going to accept the risk, I can say fine. But when you ask me my opinion about whether or not you're accepting risk that you should accept, I'm saying your data set's probably not where you think it is. That's all I'm suggesting is that when something goes wrong and everybody goes back and says, wow, how could this happen? I would say, well, did you have a data set that allowed you to accept the risk? And if you say, my perception is that we had acceptable risk, I'm like, okay, well, there are some of us who think, no, you don't.
Now, we know that Part 108, as it is written in the published proposed rules, is a bit stale. So that text was probably written 18 plus months ago. And just due to the realities of getting that proposed rule through all of the review and getting it out. And in the
Yeah, it was a
meantime,
Herculean effort, man. I mean, nobody's taking anything away from the work that was being done and put into it.
My question is, in the time since then, so much has been done with new approaches to waivers. So much more flying has been done that I think part of this discussion, we have to anticipate what the revised rule is going to look like after the comment period and after all of the new learnings and insights that we've all had are incorporated into a final rule, and really talk about what that's going to look like.
I agree with you, Peter. That's probably the best way to characterize it, because if we can insert the last 18 to 24 months into that, and look, so here's the funny thing is I'm doing this whole thing. How many people have reached out to me about what I could do with all of this data to input into it? It's not my responsibility to shove it down their throat, but I can tell you this, 0 people have called me. I'm not being asked. The DoD's not being asked. Nobody's being asked. So to me, it just looks like it's plodding forward with acceptable. And again, that's where I make my comments. If you're spot on, if somebody was telling me, hey, listen, we're getting a lot of stuff in here and we're going to incorporate it, but it feels like that's assumptive right now until I start seeing indications that we're actually going that way. Now, maybe you have more that I haven't seen because I've been heads down, and that's fair, right? And I'm calling something that I shouldn't call. But right now, I'm not seeing anybody ask any questions. They're just saying, this is the data set. We got it. We're going. And I'm like, wow, you're right. The rule is going to come out. It's going to be stale, and it's going to be much ado about nothing. It's not going to have any validity. But if they can incorporate everything that we've been doing, there's a possibility that there could be some validity to the rule.
My expectation is that they will. That between the proposed rule and then the comments and then the final rule is going to incorporate a lot of the things that we've all learned.
That'd be great. I'd love for that to, and I'd love to see what those things are, because I know what my particular input would be, right, to help out and what our program wants to do. And we're a government program, so we'll happily share. But again, you can horse, water, drink, no, maybe.
Do you plan on submitting any comments, Chris?
I haven't been asked to, and I work with the Northern Plains UAS test site, and the executive director was on the ARC. So he knows full well what my comments are. I provided my stuff. FAA knows what I think and what the Ultra program thinks and what our executive director or our program sponsor at the Pentagon thinks. But again, our job is not to force industry or force other government agencies into believing what we say. Our job is to provide the data and the delta between where we think it should be and what it is now, and help with the process. So I'm not being argumentative in the sense of this is the wrong way to do it. I'm saying I don't know that we have a complete picture to really formulate an opinion right now. That's neither here nor there. The reality is I think we need a lot more data and a lot more inclusion and a lot more conversation in order to make something successful that's going to be scalable for the future of our country.
Chris, so we've talked indirectly about Ultra a couple of times now. Why don't you describe what really Project Ultra is, how it came to be?
Yeah, so Ultra came into existence conceptually probably about 10 years ago. And that is the Department of Defense from the Undersecretary side of the House, or Department of War, if you're politically correct, decided to start taking a look at airspace integration. That's the core piece. And the UAS service suppliers that needed to be part of the system. So this is at its concept. ConOps was written by NASA, FAA, MITRE, DoD, coming up with a framework and architecture. Air Force Research Lab developed their own federal USS, that's CLUE, the Collaborative Low Altitude UAS Exchange. And NASA started getting involved in the conversation and built their UTM management network called FREDI. So at the beginning, this is a lot of simulation and test and evaluation and building out the ConOps of how traffic management next gen was going to look. Somewhere along the lines about 2 or 3 years ago, and when we were moving into our ground-based sensitive void and building out the Vantage network up here in North Dakota, the Department of Defense showed up, OSD, to take a look at our fully integrated airspace and start having a conversation with them about what it would look like to bring that in a test and evaluation perspective up here and open the door to that in partnership with the Northern Plains Test Site, University of North Dakota, and the Air Force. Because this facility at Grand Sky, where Ultra is housed, is a joint use agreement with the United States Air Force, we're able to use the digital surveillance radar feed and create ground-based sensitive void. It's the way companies up here operate beyond visual line of sight without any chase aircraft. So this little microcosm kind of became interesting to the DoD. And a couple of years ago, we penned and inked a deal between Washington Headquarters Services, OSD, and the County of Grand Forks to run a 5-year IDIQ known as Ultra. And Ultra stands for UAS Logistics, Traffic, Response, and Autonomy. And like I said, at its core, it was all about airspace integration and figuring out what the future of traffic management looks like. But it very quickly started to take on the underpinnings of logistics missions because the DoD is very interested in logistics, because everybody will tell you there ain't no mission without a logistician. So that's beans, bloods, bullet, all that stuff that needs to be supplied downrange to the combat warfighter. So we were asked very early to start doing simulation work, incorporate the federal USSs, take a look at the ConOps, do verification and validation simulated of what the ConOps looks like in the airspace, and then start putting together a process for logistics deliveries between one Kona space station and another Kona space station, in which we can exchange those DoD logistics runs, but still gain information that helps integrate unmanned systems into the national airspace system, but also provides an application process for in-theater operations for the DoD, sort of giving them a bifurcated way of looking at each one of their logistics and other types of missions. So that became Ultra. And as a result of that, we've gotten a tremendous amount of partnership with the Department of Defense, to the point that I've mentioned now that a COCOM, CENTCOM is here, with Task Force 99, with a ton of people, and DARPA and us. And we're having this amazing intersection between commercial application and logistics and all the other things that are out there, commercial off the shelf, and what the DoD is looking at with those commercial off the shelf technologies, and merging that reality in real time for the battle space operators who are here to give us feedback and provide us with an opportunity to grow and build a program that can rapidly assimilate what is needed from a warfighter's perspective and what's also needed from a integration perspective for the DoD, so that they can simultaneously build and acquire technology that can be used for downrange purposes and for here in the lower 48, which is not typical for the DoD. Something that they buy to do counter UAS in theater could never be used in the United States of America. So now we're starting to take a look at technologies and applications that could be used safely in theater, but also be used safely here in the United States of America. The constituency, those of us who live here, will say, yeah, that makes sense you're using that. And we're happy with that. That is where I think the inflection point is with the acquisition programs inside the DoD, is they're trying to say, look, we no longer have the opportunity to stovepipe application to just theater operations, because base commanders, as an example, base commanders are threatened with unmanned systems incurring or encroaching on the bases. You could never take MLIDs, FLIDs, activated here in the United States of America and start shooting down drones here in the United States of America. But I mean, that was the rapid response to theater operations when we first created those things. And those are great for overseas. Whether they work or not, that's not what I'm talking about. I'm just saying they don't work here in CONUS. So the DoD is now facing the fact that we could spend billions of dollars on a system that works over there, and then we can change it and try and get it to work here, or we can start spending collaboratively with our industry partners, not less money, but just the right money to make something that you could use here that still has an application in theater. So that is the solution.
So what you're describing is, in a way, a verification and validation or operational test and evaluation framework for the DoD.
Yes.
Why does the Air Force, Army not do that internally with their existing units?
Because right now, in the force reduction state that we live in, right, this is rapid prototyping in keeping with what the undersecretary has said, in keeping with what everybody's trying to do in the DoD memos that have come out to say that we're going to rapidly get to our process, and we're going to start shaving down the normal acquisition lifecycle process, because some of these unmanned systems, the verification and validation that is typically in a RDT&E lifecycle for acquisitions involves the fact that there's going to be a human being in it. And so if you're doing normal aircraft manufacturing for a pilot, that's one thing. But the acquisition program is starting to change over, saying, look, these are low threshold, low cost solutions that are, and the term is attritable, right? So they're consumables, right? So if you're talking a $40 million aircraft that's piloted, that's a different acquisition program than a $100,000 drone that if it hits the water, you're like, meh, get another one. So that's where things have shifted And the speed of advance is starting to pick up because these are commercial off-the-shelf technology that we get involved in the life cycle, like I said earlier, a 4-year RDT&E cycle down to a 4-day T&E cycle. Wow. I mean, can you imagine if you were in the battle space going, okay, you woke up in the Ukraine, they're using this. It's bad. We got to figure it out. I can get onto an app and I can get some information over to an engineer who can look at it and evaluate it and say, let me come up with some stuff. You test it, you evaluate it, you come up with some new TTPs, and you implement it on the spot. That's the future vision that we're talking about, is very achievable with the technology that I'm seeing up here that the DoD is bringing in, and it's all commercial off-the-shelf stuff.
Can you share some stats with the audience in terms of how many aircraft you've taken through the ringer and what were some of the surprises or insights or stories that you can share?
Yeah, so right now we're at seven. 7 aircraft have gone through the ringer. And these are all class 3s, or group 3s, right? So between 320 and 1,320 pounds. Every single one of them is hybrid electric. What I've been surprised at is the number of them that are tail sitters, which I did not expect to see from an engineering perspective, because the application for these, and this is just being fair, right, about what we're trying to evaluate, these are tail sitters that at the end of their test and evaluation period are going to be required to land on a U.S. Navy ship. And I'm being a guy who flew around U.S. Navy ships for as long as I did, I'm not seeing how it's going to be successful. But again, what we want is we want everybody to be successful, because all of these technologies have unique idiosyncrasies about them that I think need to be pulled forward into probably the future of what aviation is going to be. So to me, it's a beautiful and elegant program because we're getting more information. We're bringing more commercial off-the-shelf technology through. We're working with the services. We're working with the downrange requirements people from the theater. And we're working with the acquisition community to speed the process up, reduce the barrier to entry, reduce the onerous institutional inertia in the paperwork, and get results, and then get those results to a scalable position where we can actually achieve low rate production and then start putting these things into operational environments in theater. If we can do that, can't industry do that as well? I mean, just flat out, right? Because the stuff is coming from the commercial side of the house. So I think the proof points are being built on the back of the DoD, and we're going to very easily be able to say, whatever that is, I'm going to use, here's a great example, right? The Osprey. Think about everything that went into the Osprey. There's now a commercial variant of that, and that went through rapid acquisition. And the reason is just a scaled down version of something that already had thousands of hours on it that the FAA could easily sign off on from a safety perspective.
Chris, can you give us a walk through the scenario that you take these aircraft through? What does that test cart look like?
So the test in and of itself is 2 phases. First of all, the airworthiness phase, right? Not talking about the COTS-CTP or any of else like that. It's literally in a test environment, early stage TRL, ML kind of stuff, which is bring it out, strap it to the deck, spin it up, and watch the engines and the performance and everything else like that, to the earliest phases of hover and being able to demonstrate controllability and the ability to move off a spot and back onto a spot, to literally a higher altitude hover, to following that, a higher altitude hover to transition to forward flight and then intentionally detransition to forward, back into a hover and land. That maturation, stair-stepping level of aviation, especially when it comes to vertical lift, to ensure that you are capable of controlling the aircraft in all those environments. Once we get past a certain point in the maturation level of that aircraft, it then shifts over to what's called a military utilization assessment, where we start putting operational constraints on not only do you take off, but then you go out and you conduct an ISR mission or a synthetic aperture radar or deliver a package. Those kinds of things are the stair-stepped approach that we're working in concert with all the test and evaluation community to build awareness, not only for ourselves, but also the industry partners that we're working with, that shows them what the demand signal is. And I can tell you this, number one on the card after you can hover is logistics. flat out. It's not ISR. It's literally they want to see something move from point A to point B. So that's where I start getting an interest in what the industry needs to lean into. Is I'm sitting here looking at these industry guys showing up going like, oh, we designed this elegant package that can carry this turret ball and do all of these things, and we want to go out and do that. And the DoD looks at him and goes, great, can you just take something from point A to point B for me real quick before you do
Chris,
all that other stuff?
is that similar to red flag where you have operationally relevant simulated threats or denied environments with you have jammers that mess with GPS or comms?
Yeah, we will eventually in the military utilization assessment get to there. But right now, the simplicity of our tests is really predicated on the maturation level of the airframes that are up here. And I will say this, not everybody is getting to the military utilization assessment. We've been wrestling with some aircraft that are barely able to hover. Okay.
Have any through the entire? Have any of the airframes gone through the entire program? Yes. And what waits at the end? What's the carrot? What's the certificate, or what does the OEM get by graduating from the program?
Well, first of all, there's a payday at every stage for them, but I can't divulge that. But there is a payday for them. So there's an incentivizing moment for each of them along the process, right? So everybody, and again, I think from a government perspective, we want everything to win. This is a partnership. But the carrot at the end is LRIP, right? Low rate production. LRIP and acquisition. So I think at its core, the program wants to assimilate a certain number of air vehicles and then put them in theater and start operating them. And again, the only way to get to that is to go through the whole process of figuring out what the technical application is and the limits, and more specifically, the tactics, techniques, and procedures for each one of these air vehicles that we can adhere to. And can we train the people up to do it, right? So you can design something very elegant, but then it becomes very complicated to train.
Is one way to think about this, I was going to use Blue UAS as an analogy, but it's an initiative that's flawed on many levels, so I feel bad for using it. But in a sense, is that an equivalent where at the end of the process, you graduate from Ultra and you end up somewhere on some list where the DoD can look up and say, okay, we need this capability. Here are the aircraft that we know are capable of meeting threshold, and we will go and acquire those? Or is there something even more lucrative where they automatically dovetail those aircraft into existing budget line items?
Yeah, so I think the golden ticket, right, is maturation to LRIP, and then from LRIP to, if it's mission focused, then it becomes program of record for them to do something. Or it's just straight stick acquisition, which is the brass ring also, to say, hey, we're going to buy 1,000 units of this thing.
Right? Who does the LRIP go and serve? Is that known up front or at the end of the process?
It's known up front because the downrange end users from theater are the ones who are driving the requirements. So
I see.
This is an initiative through DARPA and CENTCOM to really provide end users with the most technically advanced solutions that they can build today.
Okay, so is it fair to say that there's a ton of emerging players who are knocking on the doors at CENTCOM and various units and saying, here's my aircraft, use it, it solves all of your problems, and then the DoD or those units are somewhat paralyzed in their ability to assess the validity of those claims, and they send it over to you. You run it through the program, and at the end, you say, yeah, these guys are good to go, and they go and acquire it.
Yeah, and so I'm going to nuance it slightly because most of what you said is exactly spot on. I would add the one statement, which is continue to work with these companies as long as they want to stay in the program to achieve the metric that needs to be achieved in order for it to be a useful end state for the DoD. The DoD is being very careful about everything. It's not just everybody who bum rusts and says, this is my solution. They're looking at it going, that one I like. We'll put you into this program and see what we can get. Maybe you can get there. That'd be great. But there is a barrier to entry and that's, I guess, when I go all the way back to the beginning of our conversation, I'm not understanding in the industry that we have any barriers to entry. It seems to me that the industry is literally everybody gets to win. And that has never been the case in the United States of America ever. And if it is, you can take your BlackBerry out and type me that message, please.
Is any part of Project Ultra's justification to improve commercial capabilities Or does it stand completely on its own as a DoD program?
Right. So I have never been given any statement by Office of Undersecretary of Defense that this is a program that's designed to assist commercial applications. What they have said is they are required to work with FAA on the integration strategy for unmanned systems that support the utilization of those systems in the national airspace of the United States of America. The extension of that statement is that there will be commercial applications to it. But the DoD doesn't wake up in the morning saying, I want to make company X more successful commercially. Their statement is, I want to make sure that this integrates well with the Federal Aviation Administration and our national airspace. Whether or not somebody's going to make money off of it is entirely up to them as to whether that works. If that makes sense, Jim. It was an answer, I guess.
Yep. Are the commercial tail sitters who were at your program who said, I can do this from a logistical application and demonstrated they were having difficult doing that, what would they learn from your program, Ultra, that they would apply in the commercial space that they didn't otherwise know today?
Certainly the comment that was interesting to me that I've had a bunch of conversations, because you realize the tail sitter comes down and it's got a big wing because they have a flying wing, right? So that's just a giant sail to me. And the conversation that we had the other day with the engineers and everybody was the understanding of what orographic turbulence is. And orographic turbulence for aviators is something that's complex, and I think it's very applicable to drones because you talk about inner city urban environments, there's nothing but orographic turbulence. That's Chicago, that's the Windy City, that's standing in between a building and feeling the air speed up as the compressibility, because Bernoulli works, comes through that environment and speeds the air up going through. When you design a drone that's a tail sitter that has a big sail that's effectively a wing that's turned on edge, and you fly it in a nice environment in a nice place, and then you take it someplace where, like a military environment, the back of a ship, where orographic turbulence is very serious, it changes the scope of your engineering design. It makes it very untenable for you to say that worked on a sunny pad in Florida, and now it's bad weather in the middle of the ocean. The drone is not going to perform the way you designed it. So people don't think about that when they're building something for the first time, that the ultimate end state application is going to be what we in the military have always dealt with, which is when you're fighting a war, it's during the worst possible weather. Absolutely. Worst weather ever. So,
Chris, what are some of the other failure modes that you've observed on the range, and what kind of advice would you give to the innovators in the audience?
So it's that subtle nuance between a remote pilot in command and the automation that's associated with it, and that transfer of control between the flight management system that's going to create the autonomous portion of it going someplace, even though the RPIC can take over. There have been some moments of aerodynamic inefficiency that's associated with that. The second thing is that as a rotary wing guy, I will tell you that many people from Igor Sikorsky to now have been trying to figure out how to dampen and smooth out translational lift, that moment between being rotary wing lift to forward flight lift. And it's still difficult for everybody. I watched drones take off vertically and then try and transition over the wing and go up to as much as 1,000 feet and lose 700 feet in altitude trying to get up to speed to get onto the wing. That's not going to work. So figuring out translational lift has been complicated for a long time. It's not something that's a foregone conclusion, and it's certainly not something that could be solved by just saying, I'm going to accept the fact that I'm going to lose a ton in altitude in order to get on the wing. So I would ask, if I was talking to people who are potential candidates, I would say, if you have no good clue of how to get onto the wing, then your design might need a revamp.
Let's say Project Ultra is swimmingly successful. What's the difference on the DoD side and the commercial side a couple of years from now?
A couple of years from now, I think we see some things that people are like, wow, where did this come from? I'll know where it come from because I'll be the one who actually recommended it and everything else like that. But people are going to say, hey, where did this come from? And it will be largely unknown. No different than any other technology that we currently work with that most Americans are walking around with on a daily basis that was built on the backbones of military innovation that is just now commonplace in the industry for everybody, right? Because there's a unclassified and or commercial variant of it. I think we're going to see that kind of quickly happen now that memos are changing, money is changing, things are all changing to try and open this up. So if we start becoming more successful, and thank you for saying that we're successful. I don't think we're quite there yet. We're on the cusp of being successful. What success means to me is in 5 years, something that we worked on in Ultra has a commercial application that actually is providing a return on investment, means to me that we did what we were supposed to do to integrate that into the national airspace. That would be what I would call successful.
Your DoD sponsor, what would he or she say is if pressed, why did you authorize up to, like, it's $100 million, isn't it, plus?
Yeah, right now it is.
If they said, why did you allocate that, what would that person say is the greatest return that will come from it?
First of all, ironically, they would tell you that we elevated it to that, but immediately realized that we did not make it high enough. That would be, they would say that it still needs to go up. And then they would secondarily say that the statement is, if we can get stuff to the warfighter faster, that's what we're going to do. And that's the whole point around Ultra. We've got to integrate into the national airspace and get stuff to the warfighter faster. And that's not a bifurcated strategy anymore. It used to be
ultra fast.
Ultra fast.
And for the warfighter, it's largely going to be a more efficient, effective, quieter logistical train.
Yeah, that's specifically what it is, and relevant. Let's just say more efficient, more effective, but relevant. I have, and I'm sure Luca has too, been downrange, and we've looked at gear that we've gotten and said, this is completely irrelevant, doesn't do anything. I'm going to put it on a shelf, and when I get done with my deployment, I'm going to give it back to somebody because I don't even know what it is.
Now, in terms of the surprises or the technologies that might come to work, and in thinking about the turbulent environment around ships and thinking about what you're observing with transitions and the difficulty that some of these designs are having, are you seeing any success with blown wing designs or other novel designs that are looking at this from a different angle?
Yeah, no, there's tremendous amount of innovation and success with that innovation in the early stages of the research and development, right? And we work very closely with NavAir, the Air Warfare Center, UX-24, right? So we have teams of test pilots and engineers and everybody who wants to do this. And the beauty that I think we're seeing is the speed of advance is actually going in the right direction. So everybody's got an idea and they want to try it, right? And then we sit back and we go, this is novel. It's a novel approach. Traditionally in A&S, in acquisitions and sustainment, that novel approach is really stalled, right? They slow that down. What we're doing is saying, hey, that's great. Bring it out here. Let's go. Mm-hmm. Because we want to fail fast. That's a different methodology, different mindset, especially for the DoD. But we're accepting risk. That risk is, like I told you, there was an aircraft that had a near mishap. My statement would have been, when it hit the deck, I would have looked at everybody and said, if it had happened, it didn't. I would have said, hey, man, there was nobody in that. And it didn't hit anything. It hit the earth. The earth's not upset about it. I'm not upset about it. The company that designed it might be upset about it, but they're the ones that did it. They flew it into the ground. That to me it's callous, but checking the block, right? I move on to the next thing. So if somebody wants to come to me with a design and say, I figured this out, I'm going to go, great, let's validate it. My process is just simply taking out what's out there and saying it's a great concept, let's V&V it. After we verify it and validate it, it's down over onto operational test. What can you do with that now? Now it gets really super exciting because some of the stuff that we're now operationally, it's validated in the test world. Now we're operationally validating it. I literally walked into this process for this particular program with DARPA and CENTCOM 6 weeks ago. I didn't even have the stats on the drone until we were a month out from test and evaluation. And then I started taking a look at it, like from my traditional methodology in aviation, I was shaking my head going, some of this stuff's not going to work. Some of the stuff that I thought wasn't going to work, works great. And I'm sitting here going, wow, I need to change my whole mindset. I was wrong. That's okay. I get to be wrong a lot. And I hope I am wrong a lot. But the reality of the circumstance is we still are going through the same process. There is no acceptance of it's going to work. We have to prove it. And after we prove it, then we have to employ it. And then we have to develop the tactics, techniques, procedures so that we can make it completely usable and scalable. Now that we're doing all this stuff, I can see an end state where the commercial applications for some of these drones is immediately there, and they will perform, and they will perform safely.
Excellent. Well, we could talk for hours. Unfortunately,
which I warned you about, Luca. I warned you, especially
you
bring Peter in. Bring Peter into the equation. Peter and I could talk for 2 days.
That's the risk, but hey, it's a risk-based approach. Thank you, Chris, for coming back and sharing your insights. It's always great, and we look forward to having you back again without waiting for another 2 years, but wish you all the success with Ultra.
Thank you very much. Appreciate it.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.